Hello, 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 everyone. We are back with another Fusion Friday. We're going to give this a few minutes before we get everything kicked off. I want to make sure everybody gets a chance to get in here because the notifications usually go out almost immediately. There's the notification on my cell phone. For those of you already joining us, let me know if my audio sounds okay. We actually added a brand new computer this morning and was getting everything set up. And little did I know that my mouse was interfering with the way it was hitting the desk versus the microphone. So again, we'll give this a few minutes as all of you get in here so we can see the stats, make sure everybody's joined. I know a lot of you may be coming off lunch break, maybe starting your day, who knows, right? Long cycle times. So awesome, Bod, I see you out there. Anybody else out there? Am I sounding good? Not too loud, not too soft, hopefully better than ever. As we all know, I have nothing but the best of problems as we have these shows go on. Awesome, Dylan. Great to see you. Again, I'm waiting for the stats to come through. As we wait for those stats, as you guys know, Fusion Phil over here, if you're new to my channel or you're catching this episode for the first time, we offer up free support here on the audio and video is great. That's a first. We might break a record this week. But as you guys know, you are more than welcome to ask questions at any time. I do have a subject we're going to kick this off with, and we're going to be a little quick about. But it actually goes out to our channel sponsor, or I shouldn't say channel sponsor, video sponsor this week. For anybody and everybody out there, I see we got 6 of you guys in here. We're going to give this a few more minutes, but I am going to give them a shout out, and we're going to, of course, crack open the energy drink of the week before I enjoy all those beers after we do this. So again, if you guys have any questions, feel free to join us in Discord. Feel free to put in a support ticket down below or even put anything inside a chat. So with that, let's go ahead and pivot real quick to this week's sponsor. This week is they have provided the content and actually bought me way more than a beer. They've bought me a keg, I'm pretty sure, in equivalence. But that is LN Engineering and Flat 6 Innovations. If you guys don't know who they are, for some reason, I think I've been nominated as the car guy for CAM nowadays, but they specialize in Porsche engines, and they've reverse engineered a scan, and you're going to see that here shortly, but this is a Porsche 911 M96 coolant plate that we're going to start working on, and if you guys have questions at any time, again, feel free to ask them. I'm happy to stop and visit on those questions and make sure that everybody is accommodated accordingly. So let's go ahead and crack open the good old energy drink because I'm not going to drink a beer on stream. But as you can see, we went with the old Celsius again this week. So Celsius, if you're out there, feel free to send me a case. So let's go ahead and dive into this part. So I already have my part pulled up. And what I actually really liked about these guys' part is they actually provided me a unstitched model. Now I see this quite often in the world of Fusion. And it's a great problem to encounter from square one. So if I expand out my body, as long as you guys are seeing this, is we have everything and anything, and this is what's considered all unstitched surfaces. This is very common where if I went in, I could still kind of select everything in one shot. You know, I wouldn't really know that they're unstitched surfaces, creating a non-watertight model until I got into the CAM portion, and that's when I see it most when somebody can't seem to select the edges they want in the profiles. Now, another dead giveaway for me over here is the fact that the multi-coloring of the different surfaces. Now, you can apply different actual surface coloring or texture kind of images on these parts. However, when you have one part, no assembly, it's a little suspicious. So how do we remedy that? Well, what I'm going to do is I'm going to go up here to the top to my lovely surface environment, and we're going to go ahead and hit stitch. Now, I want to stitch everything in this, so I'm going to go ahead and grab all of these unstitched surfaces in one shot. And I don't spend a lot of time talking about this, but this is a great moment. So as you see that green edge, and if there was anywhere that was not stitchable, we would see that in red. But what that is telling us is based on a gap tolerance, is it is allowing us to automatically go in and stitch those edges together. To give you guys an example here, if I go in and let's say we remove this one surface, and now I went in to stitch everything, what you're going to notice again is we're now getting red edges here where it's unstitchable, right? Now, if I was to really increase this tolerance, what you're going to see happen is at some point that would become stitchable, and it could actually ruin our model. So let's go ahead and go back. We're going to go ahead and undo that last thing we just did, because I want to stitch everything all up in one shot. So again, once we hit OK, you're going to notice all those orange surfaces are just going to disappear. And just like that, Fusion has gone through and actually fixed to create our watertight model for manufacturing. So let's go ahead and change from here over into manufacturing. Now, some of the things these guys have reached out to me about is they've already declared to me that they're guilty of the number one thing that I strive not to do, and that's using 2D roughing strategies. So when presented with a part like this, as you can see, this is something that you could do in possibly 3 operations, because you are going to have to put an MPT in here for coolant. But in their case, they actually have a 5-axis machining center. So now there's a couple of different ways to think about this. Is how can I hold this later on? Or, you know, if I was to stay in a 3-axis world, am I going to have to make soft jaws or something of that nature? Now, me personally, if I had a 5-axis, and so you guys know, I actually have photos of this. I should pull up these photos and give you guys some reference here. Is this is the actual location where this plate goes. Now, this original plate is a casted part. It's known for failure because it also holds an alternator on it. But what they've done on their end is they've actually went in and already 3D printed a prototype of this. So now we're transitioning, and again, this is why I like this whole idea of this. We're transitioning from that prototype that was 3D printed to let's machine a part, right? So there's 2 sides of machining when you think about that. And one is, do I got to make one of these, or do I make, 100 of these? Well, given their circumstances with a 5-axis machine, I'm thinking we might just be able to do something with tabs and do this all in one shot. But I'm going to start by throwing some toolpaths at it to get a better understanding or thought process on how we could do this. Let's go ahead and create our setup. In this case, I'm going to go ahead and set my Z-axis based on a flat. Now, my stock here, as you can see, is coming in a very square based on the world coordinates of everything. So by picking my X-axis, as you'll see here in a second, if I was to sit square along that edge, automatically my stock is now recalculated to a much more manageable shape. So again, we can go to our stock side of things. I'm much more a fan of a fixed size area. And from there, we could actually say, instead of being offset on center, we're going to go ahead and offset from the top 20, because I'm going to go in and probably deck this off or clean these flats up. So I see Brian out there. I will come back and we'll do some tab work here with a 5th-axis vise by all means, but picture frame using tabs. Yeah, we did cover that last week. It was pretty wild, wasn't it? So as you can see, we have everything set up. Looking at this part, there's actually quite a bit of detail on this side. Maybe I machine it the other way first. I don't think there's really going to be a right or wrong reason here. But I would tell you, I'm a big fan of 3D roughing strategies. And I think a lot of you are starting to catch on to that. That in this part, again, based on my shop crib, you all know this. We're going to go ahead and grab our 1/2-inch flat end mill. We're going for those speeds and feeds that we have. And then from that, again, we're going to let Fusion basically do its work. So I'm not going to give this anything until I have to, or adjust anything that we have along the way. And as you're seeing, and this is probably going to be a big shocker to these guys over there, can't wait until I'm out there February training them up in person, but we can do a lot in a short amount of effort with just one toolpath, right? Now, I picked a bowl end mill because, again, as I may want to rough this with a different tool and finish it with a different tool later. But when we start to talk about now, how do I clean up the floors on something like this, I'm going to go in and use a horizontal toolpath. And my favorite thing is to actually finish my floors before I finish my walls. So we're going to leave 25 on the walls, 0 on the floors. And then we're jumping straight into that flat strategy to clean up anywhere on this part that is flat, as you can see. Now, getting into this a little further and a little deeper, we could start to finish up the walls. There's a lot of ways to finish up walls on a part like this. What I'm going to do is either go to 2D. Now, this is where I make that decision. If I don't have critical features, I like to finish things with 3D, right? 3D contour, as you guys are going to see, this is another neat trick that you have the ability to do. So we're going to actually say tool all the way to the outside of the silhouette. And then I can adjust my maximum step down as much or as little as I need. But with that, we're going to go ahead and let this just give us a toolpath so we can make changes. Now, again, we've kind of talked about the concept here is I'm going to make one of these as, or maybe 2 or 3, or I'm going to make one and I'm going to fit it based on, that part. I might have to come back to the design and make a couple of changes. But awesome. Fun facts. I see you out there. Great to see you coming in from Canada. Now, that was kind of a cheating way to go about it, but it worked out quite well, right? In the world of machining a prototype or form fitting something, as you're seeing here in our machine time, it's really only going to take me 10 minutes. Am I going to gain anything from saving 2 minutes on the cycle time? Not really. That's why you're going to see tricks here that I'm using where I'm just going through, picking a generic profile to cut something out, and now being able to actually take this to production, I may ramp up some of those settings, right? I could go in and we could say, maximum step down is actually 0.2 instead of 0.05, things of that nature. And again, clean this up a little bit more. We still have some areas that we may need to make multiple passes at. But the idea is with these tool paths and the way they recognize our part, we can do things relatively quick. Now, a few other things I may do, because this could be a critical mounting hole. This is where I like to use things like the ability to actually say, avoid a surface or go in and actually leave material on this, right? So I'm going to go ahead and stay away from this wall by 20. And again, we're going to recalculate that toolpath. And as you're going to see now, it's avoiding that surface by 20 thou. I may have typed in something wrong because we've caused a lot of other chaos in our part. But let's go ahead and change that up to maybe 0.1, 0.01. And let's go ahead and undo both of those just to see that maybe I'm not crazy. So as you're seeing here is in certain cases, we are having dilemmas where we are still with that avoid touch surface not really being fully up to par. So maybe I would go back on this specific part. Again, we just want to build a prototype. We kind of want to do it quick. I could go into my surface area. We could throw a patch on this. Jumping back into manufacture, we go to our toolpath. In this case, I'm going to use the model feature and add this patch to include the setup model, right? And I've did a workflow Wednesday diving into this more, but as you can see, there's still certain workflows in Fusion that work great just to go back, sometimes patch a surface, remove a surface to get to kind of where you want to go, right? And we could do a lot more with this. There's no minimum kind of system here. We could say machine shallows. What machine shallows is going to do for us is add us more steps in all these shallow areas, blend in, start to clean up these edges that are actually filleted or chamfered around our part. So I'm going to go ahead and give that a break here for a moment. I see more and more people getting in here. You guys have any other questions outside of this part? We're just going over this part until one of you asks some great questions, as you always do. So as you guys are seeing here, we've went ahead, roughed out that part. We've possibly cleaned up our walls. If I wanted to change my strategy overall, maybe I'm thinking, you know what? I want to see what this looks like machining back the other way. This is what I love about the fact that we can quickly go in, flip our Z-axis, and what you're seeing, because of how I actually went in and did those strategies with 3D toolpath, I can very quickly go back the opposite way now and see if this is going to be a better approach for everything I'm doing. Now, keep in mind here, again, we do have some features that I may or may not want to do or avoid. I would still need to go back, possibly add a patch on the backside instead to be able to achieve those tasks and avoid manufacturing in those areas, right? So again, what you're seeing me do is I'm just going to add that patch in. Maybe we want to avoid going down in that specific hole more than that counterbore. But again, form over function. We're not going into production on a part like this. We want to get it good enough so that we can test fit what we're doing. Now, from here, we could start to pop some holes in this and drill it. As you're going to see here, we're going to go ahead and go grab our spot drill as we pretty standard do. There's a 3/8. I think the 3/8 is going to be a little small, or actually it's going to almost work out perfect. I see a lot of people overthink spot drilling for some reason. Since we have a model surface, If I pick that surface, my tool is automatically setting the depth to go into where that surface is. So from that, we could do our same size diameter, and we could go out and find all of those features. Now, some of you may be recognizing why I kind of finished out these bores, and I'm drilling this on the back end of things versus drilling it in the beginning. I don't think there's a right or wrong. There's been times where I've had to drill the holes in the top of the stock to start with, and then come back and do my machining. But again, the idea is because I lucked out with modeled chamfers, I can go through and I can just pick that surface and predetermine the depth of that chamfer when spot drilling. From here, I'm going to show you guys an example of if you don't have a modeled chamfer. So let's do my favorite thing, go in and break a perfectly good model for no reason. And jump back into the manufacturer workspace, and we'll just regenerate that spot drill. Now, if you're dealing with a hole that doesn't have a modeled chamfer, you could always add that chamfer in the design workspace. But let's be realistic. You guys are like me. We're lazy. We're efficient. Just don't ask our wife. Our boss will tell you we're efficient, right? So this time round, if I was to do drilling with a spot drill, again, I pick my geometry, which is this hole. Now, there is a setting in here that you have the ability to, instead of saying hole bottom, I could actually either go to a diameter of the chamfer or the width of the chamfer itself. So if I wanted to break the edges on these by 20 thou, first off, you have to type 2, not 1. But as you're seeing me here, I'm typing in 20, and now it's not only going to the right depth, it's doing that with the addition of the tip in going down for that 20 thou chamfer. Again, two completely different ways when you're getting in here and drilling out these holes in these features. So as you can see, we're moving quite along. It's relatively quick and easy to get to this point. We're going to go ahead and regenerate all of this so that that stock model comes through automatically. Let's go ahead and check some of our errors. One or more of the pockets were not machined because they were too small. We could take a glance at that as well. What that's telling us is we're not able to go down and finish these floors in these pockets. So that's another thing that's happening on our model as we're machining. So we need to be aware of that. Good news is when we go in and do our machine simulation, we should be able to see anything and everything that happens. So again, we're going to go ahead and run our verification. If there's any collisions along the way, we should see those collisions. And as you're seeing, we're machining out all those surfaces, doing all of our blends. Again, one thing that is happening is when we're 3Ding down to actually create these profiles, we're not actually machining them from when we roughed them. So we may want to make a couple of changes there so that we're not slamming that tool in. And again, something so you guys can keep a note of this on your own is because we didn't have a modeled chamfer, we do get that red edge here where our tool hit the part. But again, that's because we don't have a modeled chamfer, but we are chamfering that edge when spot drilling. So guys, any questions so far on this? Anything in particular you want to see? I don't want to bore you all to death when we go in and flip this part over. But the neat thing is again, with the way Fusion works is if you set your tool paths up, which as you're seeing, I'm using rest machining from previous operations. So when I needed to flip this part over in the imagination stage, as I call it, right? Customer wants me to quote this. I got to run this later this week. I got a few minutes to play around with it. I'm actually just going to go in and duplicate my first setup. So what you saw me do there is Control D for duplicate. We go in. I'm going to go ahead and uncheck flip in my Z. And then I'm going to allow this to be from preceding. And I want continuous rest machining check. What that just did for me is automatically brought through all of the stock from one side to the other. So if I go in now and I hit regenerate, Control G on my keyboard, for you Mac users out there, I think it's Command G, but my roughing strategy is starting to work back the other way, but it's not aware of the stock. So let's fix that. So we go into our settings. Now I can go in and I can define a lot of different ways. The remaining stock should have actually picked up on this. So let's go ahead and see why that didn't do it. I always love when it puts me on blast here. So we machined one way. We're machining back the other way. Let's go ahead and regenerate that one more time, and we'll take a second glance at it. For those of you that know the problem or you've encountered this, go ahead and put that in chat to get me going. Would I recommend 3D roughing on a lathe? That's a good question. So it depends on what you're doing. But last week we did cover where most times on a lathe, you're dealing with a patterned profile. And sometimes it's easier to do a 2D roughing on a simple profile. Now, if you gave me a part that was pretty organic and weird shaped, it'd be a completely different story where I would probably go 3D. So let's investigate this a little bit more and see what the problem is. So we are going from proceeding. Let's go ahead and do a silhouette from setup stock and see what that gives us. And again, we could play around with these tool paths more to see why we're not getting the recognition from one way to the other. Again, I'm going to check this contour out as well. And as we can see in this contour tool path, we don't actually have rest machining turned on. So that is why that contour path isn't coming through. So again, now that we have that contour path turned on, you are starting to see where this is going to go in and machine in areas, but it may be avoiding certain areas because of other settings. With that, I see a lot of people coming and going real quick in here. Do you guys have any questions as you're showing up? Go ahead and put those questions in chat, as somebody just did, asking about 3D toolpaths on the lathe. Again, we're going to go back. We're going to say remaining stock from setup stock, and let's see what that gives us. So as you can see, very minimal changes in Fusion makes big differences at the end of the day and can and cannot cause more problems downstream. Let's go ahead and go back to our adaptive clearing. And as we're kind of encountering, it seems like we almost have a bug happening inside of Fusion. So hopefully Autodesk is catching this in real time as to why this isn't working properly. And what we should be seeing is actually the identification of the material already being removed and only machining where that model is. And for some reason, it keeps going all the way down. So again, moving a little further on, we'll come back to this here a little later if we're not getting any questions. I spoke too soon on the front side where our back side doesn't have any edges. So again, as this is where we were talking about spot drilling on one side, let's go back into our other spot drill. We're going to go and pick our face, all the same size here. And again, we're adding that 20 thou to break the edge on the backside. So I see Matt Van Loo down in chat talking about, do you have continuous rest machining? I do have continuous rest machining, 100%. So we went from proceeding, continuous rest machining, and then in our adaptive clearing toolpath, we are using no boundary. And with that no boundary, it should be defined by remaining stock. And then from that remaining stock, we should be seeing either from setup stock or from previous operation, but it could also be the reduce air cutting. And let's give that a look here real quick and see if that makes any change. So on my new setup, I do. So when we go into our setup, I think there's a little bit of a delay. I went ahead and did from proceeding and continuous rest machining. Delete it and do it again. Yeah, somebody's telling all my secrets, right? I have seen that. So if we go back and we just create a brand new setup, again, we pick our Z-axis, we're going to flip it, we're going to define our X-axis, and then with that, let's go ahead and say from proceeding and continuous rest machining. And let's see what happens when we throw that 3D adaptive back in it a second time through, right? Funny if it works. But nope. It's still not recognizing the fact that there is material that is already machined away, right? Now, one thing we could do is possibly bump up the fact that there is ignore material less than 20. But seeing how we finished the walls in a lot of places, it should actually come through with no problems. So we could increase the tolerance. I don't think the tolerance is going to make a difference on this scenario. I would be curious to say is what happens if we maybe cheat the system and go to pocket clearing and see if there's something in the background that's a little different, right? So again, we have from previous, and let's just see what we get. We'll throw that same tool at it. Again, not caring about speeds and feeds. What we're caring about is the model recognition. So as you guys can see, I've kind of set you up for failure here, which always makes me laugh. But what's happening is for some reason, and I got this question earlier this week, the adaptive clearing is not recognizing on that flip. Now, again, we're still getting that error, certain pockets not being machined just by this profile. But as you can see, based on the actual physical stock model coming through, it actually is now ignoring the lower half of the part that was machined away in the last operations. So again, something just different. Maybe it's me, maybe your Fusion does it too. You never know until you get in here and start playing around with it. Is something possibly happened along the way in the lovely world of updates, right? So again, is if we say none remaining stock, again, from previous operations, as you're seeing, we should get the same result as we just got on pocket clearing in 3D, and I don't believe it's coming through. Again, you'll notice it goes all the way down, and just to test this one more time, let's say we go in and do a derive into pocket clearing, and then I will have to reorder this, so let me drag it up and regenerate it. This would actually be a pretty good example, because if we are ignoring rust machining here, and we're going to find out, is notice how the 3D adaptive clearing toolpath is still finding things as funny as it is, right? So it still thinks all the way down to the bottom there's something there. Any questions so far? I see more and more of you coming and going inside of chat. So as you can see, there is little hitches inside of Fusion. Again, you could go in, possibly ignore stock less than 30. Again, we roughed everything out to 20. Increasing the amount of stock to ignore actually helps a lot with getting rid of a lot of whisper lines. But I believe this is just a random bug that we're seeing nowadays. So again, pocket clearing in this case went through and actually fixed everything for us and ignored where that stock was. Again, not the most ideal thing in most situations, but still achievable, right? So from that, we could go ahead and continue with what we were doing. Let's go ahead and snatch up the other two toolpaths. We'll repost those down below. And again, we'll regenerate those on that flip. So Roy, you get a lot of empty moves while using adaptive toolpaths. I've seen that a lot too. And usually the best way to look at it is by increasing that stock to be ignored has a tendency to actually change a lot of what you're seeing. And I see that, me personally, I see it when I go from like a 1/2-inch cutter to a 1/4-inch cutter. It seems like that there's something in the STL model that's being generated in the background for your stock model that it thinks there's more material, or it's starting to see the steps, and then you can avoid that now. Now, there is another secret couple areas that we'll look at here in a second, but as you can see, we're coming back with that horizontal toolpath. Again, we have a lot going on in that contour toolpath. So if we go into our contour toolpath, yours truly forgot to turn on rust machining. And now we should see a lot less at the contour toolpath. Again, we're still, for some reason, at this end of the part, going down past the part, even though we've actually machined that all away. Now, something that some people don't know exists is you can go in and you could do a compare and edit across multiple toolpaths in one shot. I did a video on this. It's super cool to be able to come in and actually look at your preset speeds and feeds. And if I wanted to, I could go in and now for the pocket, we do aluminum roughing, and then the horizontal is going to be aluminum finishing. Granted, you do have to set up your tool or your tool speeds and feeds at your tool level. But there is additional things in here. This actually gives you access to certain areas that are almost hidden in the background. You have things like chaining tolerance, which is night and day difference than toolpath tolerance. And we could actually search tolerance here. And you're going to notice there's a lot more here than a lot of people think. So you could go through and have additional secret settings in here. Surface triangulation tolerance is one that I would love to point out. But you can actually modify your toolpath much more than what you're seeing at the highest level. Now, some of these are built off an expression, so just know this is half of whatever your tolerance is set to and things of that nature. But your actual surface triangulation tolerance is, from those of you that don't know, surfaces are actually built out of triangles. So now you're adjusting, the tolerance against that triangle, which is the physical model of what you're working with. But again, another pro tip for a lot of you guys out there, you have that ability to go in and do this on your Fusion, adjust it down more. You can actually change how fast your toolpath calculates there or how accurate your toolpath is calculating. Now, before you guys ask, is there a reason for Autodesk to add that into all the toolpaths? Sure. Feel free to comment down below and tell them that you would like to see that in detail explanation at the toolpath level for you guys to use. So from that, we could go ahead and pivot a little bit here. Now, as you guys saw, we've kind of roughed it one way. We've kind of roughed it back the other way. Now, I'm not going to spend a lot of time on the nitty-gritty stuff here. I do like to talk about MPT threads. I believe this is MPT. For those of you that haven't caught my other videos, MPT threads, of course, are tapered and they're a pain in the ass. So number one thing is to have a surface that references that, right? So what I'm going to do is I'm actually going to jump back to design here. Now, I don't have the exact data in front of me, but as you guys can see, this is a 438 diameter hole. It is a diameter cylinder. It's not a cone. If I was to MPT this, I would probably go in and add my draft to the surface. Again, that draft allows you to set an angle. In this case, I'm just throwing 1 degree at it. And I think you all can see out there that that is now a tapered shaft. Or if I go to 2 degrees, 2 degrees is overkill and it starts to break the model. But with that angle for my taper, when I do my thread milling now, it will actually chase that taper. And we'll see that in the toolpath. Let's jump back to manufacture. Again, I'm going to actually do this based on a thread toolpath. We're going to do tool orientation. Again, later on, we're going to talk about putting this on a 5-axis, right? So we're going to go ahead and define our Z this way. Again, our X-axis won't actually matter. If you're on a 4th axis, it can. Usually your post-processor takes care of that all for you. But now what you're seeing me do is select my circular face. Of course, yours truly is going to make the mistake of not having a tool proper to do this. So let's go ahead and go select the tool, or I'm just going to make a tool. Let's go ahead and find our thread mill tooling. I am blind as a bat today. It is Friday. I'm already looking towards the weekend. So there's our thread mill. Thread mill diameter. Let's go ahead and change that down to 0.3 just to make sure it fits inside the hole. Again, you have your number of teeth, your angle, and what your thread pitch is. So go ahead and hit accept, select that tool. And now if we look at this straight on, you will now see that that taper is happening as we run down that cylinder, right? So now we're getting that cone profile. Yes, we're going all the way to the bottom of the surface. We could change that. We could say, you know, full top minus whatever that distance is, maybe 0.5, creating that MPT thread. I'm going to pause there because I see John has a question in chat. I have a surface made in a part that is the shape of MPT threads I use, and then I drag them into an assembly. Yeah, I mean, you're not wrong on that statement at all. You could 100% create a surface and make basically a hot fix to place that surface. Yep, so it looks like confirmed. It's not just me, and I know it's not just me because the great world of you all working with yours truly over here and seeing this content, somebody on Monday was pointing out that it wasn't doing what it was supposed to do. So it seems like I always give it up to, is it one person or is it all of us? And it is definitely all of us having this bug and issue with the adaptive clearing not recognizing the stock. Now, Autodesk, if you're out there watching this video, whether it be later or right now, feel free to put in chat or leave a comment if there is a fix or if this isn't on your radar. I'm happy to also provide any models as needed. So as you can see, MPT threads completely doable. Another thing most people don't recognize is usually you would probably drill and ream that angle in there, but who's going to go out and spend a couple $100 on a reamer, right? So we could go in and we could actually 2D bore tapered holes as well. Some people forget about that feature inside of Fusion. That again, I'm going to go for Old Faithful here. That is going to be way too big. And we're going to have to switch out Old Faithful for a smaller tool. So let's go see what I have in my shop crib laying around to make more problems happen. There we go. We got a 1/4 inch end mill. Again, perfect world. We're going to use aluminum. We're going to define our tool orientation. Again, I can pick my Z axis. We now define our face selection. And as you can see, we could actually bore down into that, again, creating that cone-shaped surface. Once again, you have your angle, all of that stuff. I would recommend if you're going to do this, we're going to go ahead and turn on wear. So with the first time you go through and you bore it out, you may need to check it and see if it's proper for that MPT to work out. Now, if you're like me, you always look for the most efficient way to do stuff, right? As you saw, I had to make a lot of mouse clicks, even though I already had one part of this done. Whether I was doing the thread, whether I'm doing the bore first, this is something I even forget nowadays, right? Is the fact that you could quickly jump from one tool path to another, bringing through your tool orientation, bringing through certain selections, and automatically defining that across two different tool paths. So what this is prompting me for is now, hey, I have yet to bore that out. So it said you can't bore with a thread mill, give you a new tool. But as you can see, by placing one before the other and using one with all of its selections. So I got a few more information coming into chat right now. So I have a similar part and typically set up 2 adaptive for the second op. One from the top to just under the first operation, remaining bulk. Yep. So I've done that before. I call that kind of like the cheeseburger or the sandwich method, where you get to the meat in the middle and you meet at the, you got bread one way, bread the other way, and then you can meet in the middle and kind of do the same thing and overlap the two. So it's been that way as long as you can recall. Well, good thing we're seeing this live and now it's documented. So Autodesk, if you see that, John out there says it's been there forever. You guys need to come in and do something about it, right? So let's go ahead and change gears here, right? So we've kind of talked about this. And from that, I'm going to pause, though, because I see another one. Is there a way to pre-drill? Is there a way to change pre-drill feed rates other than manually in the G code? I would need a little more information as to what you're requesting from a pre-drill feed rate. So are you looking for a slowed down actual feed rate prior to entering a hole, or are you looking for your end mill actually slowing down and plunging into a part? But let's go ahead and go grab one of my lovely jigs and fixtures that you guys absolutely love. So we're going to go ahead and go out, and we're going to look all over the place because I never remember where I store anything. For all of you, you would have a nice project full of this type of stuff, right? So I'm going to go with the standard jigs and fixture template, as you all are very familiar with. And if you didn't catch my video, we talked about how to actually set up center of rotation on Wednesday. But I'm going to go back to design, and we're going to go ahead and do the famous file save as, putting this back where my other stuff is. So again, this is a good habit to get into. We now saved our jig and fixture over to that other area, so we're not going to interfere with anything. And let's get back to our part. So as you can see, I have a pre-built jig and fixture with parametric control. I'm going to activate my part, and then we're going to take that lovely part that we've been working on and stick it inside of there. Now, I'm going to leave it alone for a second because I'm noticing here, and this is a great thing, is in my data panel, you can see that we haven't hit save yet. We're still on version 1. So let's go back, hit save on our part so that we can push all that data through. So as we're going to see now, we're going to get that warning because our part is linked back to the original design that we need to bring that latest and greatest through. And I see another statement coming through. When using multiple passes, multiple tool thread mill, it will wrap it above the part every pass and not stay down in the hole in between each pass. I believe that is a question or a statement. Let's go ahead and take a look. So again, we're doing our threading. I'm going to go in and say we're going to do either multiple threads, or we can go through and set up multiple passes. And from what I'm hearing is it sounds like it rapids all the way up and out. So let's simulate this and see if we can catch it here before I have to go look at the G code, right? So we're threading out. Go ahead and make our stock a little more transparent. Yep. So it is rapiding back up and out and then coming back into the bottom. And the reason for that is, let's go ahead and look at our heights tab. So in my heights tab, we are starting from a retract height, right? So we do have a clearance height versus a retract height. Now, because of the way my stock is, we're staying 200 above the highest point, which would be my stock in this occasion. So if I wanted to adjust that, we could adjust that, and you could set that to whatever you need it to. So I could actually say this is from a selected surface and go in and define that surface And now we should shrink that up even more. Now, there is additional settings outside of that in your linking tab can also affect the problems you're having. So I've seen that in some cases where you start too high, you don't start high enough, leads to center, things like that. Awesome. Multi-tooth thread mill. Yep. So a multi-tooth thread mill, you're probably still going to get that same result, right? So if I went in and edit my thread mill, and let's say we have, I don't know, 5 teeth on this one. Same kind of concept is going to happen. It's still basing all that information the same. So we got our jig and our fixture. We've talked about doing this based on 5-axis. Now, as you're going to see, everybody was asking about, let's do tabs, right? We did tabs last week. Why not do tabs again this week? So in the world of 5-axis, we really wouldn't care if this actual MPT fitting sat square to the end of our part. Now, I could do some Hollywood magic of doing a joint based on that cylinder face and getting rotated over, of course, standing it up, and then trying to get it placed wherever I need it, right? Now, as you're seeing, is the goal of that stock in the background is nothing more than a idea of where is that stock centered on my part, right? It's undersized, but as you can see, I can actually get very close to placing it. The problem we're going to face here in a minute is because we've actually fixed the part off this end, that if I was to now oversize this stock, again, what we're going to see now is we can go to, let's say 3. Actually, we're going to have to go up to possibly 4. And then our length is going to be closer to 6. Is now notice how that part has shifted out the end. Because again, we told it from this end a certain distance, right? So again, I'm going to go and try to narrow this down. That actually fits within that stock size. So now with that stock size being defined, I need to change how we did that joint, right? So as you can see, we could actually activate everything as a whole. I have that joint down in my timeline. If I wanted to bring my part back in, I could do so. Another thing I could have did is when we set up that joint is I could have placed it against this flat over here. Again, redefining based on the bottom center of this surface. And now it's a little tricky to see, but usually you get a rectangle, which is that rectangle center of that surface. Again, fully editable and changeable based on where you're trying to go with it. So now we could bring it in. I also could have, instead of bringing it in, we could have did a flip. Again, rotating it and placing it. A little more of a manual process at the end of the day, but I think it gets a little bit more of a nicer output for what you're trying for. Again, we're going to do some tabs here, so I'm going to bring this up as high as possible. And now that will allow us all the room to place our tabs. Again, the orientation of the part isn't the most important thing right now. What we're really going for is how are we going to machine this and hold on to it, right? So when it comes to tabs, in my opinion, I like to actually just create a sketch against my stock. And then from that, I usually just use nothing more than a couple of rectangles. Now, since the addition of fixture recognition, we used to actually have to concern ourselves with possibly dropping a rectangle down here and almost making like a trophy base. We no longer need to do that in the world of Fusion because I can now actually just model up my tab and I'm just going to overlap it a little bit on my part and a little bit in my jig, knowing we're going to stay clear of that. So again, what I'm going to do is two-sided. What that allows me to do is bring the first one in and get it placed however deep I need it. And then from there, we're going to go ahead and bring in that second one. So the reason why I like this method is because I have full control over those tabs. Again, going back to that mindset of how can I manufacture this part long before we actually get to the machine, right? So there's my first tab. Little right click, go to the north. We can actually go in and do our second tab where we need to expand out our sketches. And now we can grab our second sketch and set that up as well. In the meantime, while you guys see me fumble through this, if you have any questions, feel free to throw them in chat. Again, we're here for you all day until 3 o'clock or possibly longer. So again, we have our second tab, new body. I think I failed to do new body on that first one, so let's go ahead and add in that new body. And now you can see we have our 2 tabs sitting in our part with that ability to go in and machine them. Did it give us a new body or is it being difficult today? Let's see here. But let's go ahead and delete that one and just recreate it. Can't be perfect all the time, right? Again, two-sided. Go ahead and drag that in. Drag this one back. Hopefully this time we remember to say new body. There we go. There's my two tabs. My two tabs are sitting in my part. They're also low enough now. They're down in my jig and fixture. So if I went back to manufacture, again, working off our setup here, I'm going to delete this setup because we're going to start from scratch. We did end up with our actual patches floating out in space. And what I'm going to do is create our setup. Again, I'm going to walk through my process, right? So Z-axis up, X-axis along my part. My actual model manufacturing, we're going to go back into our design tree. We're going to make sure that we grab our model. Now, our fixture, this is very important because we want to bring our fixture and everything through as well. So we can go back in now and pick out our fixture and all of our fixture settings. And I see somebody starting to get a little wild in chat with questions. I'll get to you here in a second. But as you're seeing me pick my fixture, again, now my stock can be from solid. Normally, when you set up your actual jig and fixture like this, we've actually pre-selected all this. So it's going to automatically define everything. Again, what I could have did here at the setup level is actually had model selected based on the part component that we had. And since we're going to use a 5-axis machine, we have that placed on the table automatically. So let's go ahead and look at chat and see what we have. So a couple of examples. I want to enter a hole in the center with a tool, adding a pre-drill position. Yep. And then a pre-drill. Okay, so you want to enter, so you want to plunge down on the inside of a hole and then machine outwards. So if you wanted to do a hole in this case, and we'll use this part, is if I wanted to actually plunge down on the center, is I could actually do a circular toolpath if this was something you're going after. So the nice thing about circle and bore, it actually has the ability to start on center. If I remember correctly, let me go back here. You do have it in bore. Where is it here? Lead to center. And you should have that in circle, unless it's going to make me a liar as if it's gone. Nope. So you do have lead to center also here. So if it was something I was trying to do, there's a lot of different ways to achieve it. But let's say I do circle toolpath. And again, we'll go for my favorite tool, as you guys know. And now what I'm going to do is we're going to lead to center. And then I'm going to pick my hole. And now based on your step downs, again, we're going to do the math from hole top to hole bottom. So maybe I only want to make one pass, right? So I could set my step down very dramatic, pausing that one step down in center and then leading out and around to clean that up. Now, if you wanted a different feed rate for this, this is the great thing about actually having a custom feed rate for this situation, because you could change your plunge and your lead in, lead out feed rate to accommodate that, right? So if we changed our plunge rate to maybe 50 here, what we can see is setting that up to plunge down in the center based on the plunge feed rate. So that would be a different way you could approach that scenario. So I see another question coming in from Deep Thinker. I have a question on that MPT thread. You have just a straight drill hole on the model during programming. Do you have that hole tapered? Yeah, so you may have missed it, as I actually applied a taper to that hole. So I changed the surface to be a tapered surface and make it easier so that when I go in, and as you're seeing is we really wouldn't need to pre-drill it because we bored it now, but you should see in that actual bore toolpath, it's starting to cone and fan. And we would 3D that unless you spent the $500 on the reamer to do so. And then my actual ability to do my threading cycle was going to chase after that, right? So again, getting back to jigs and fixtures, we go ahead and have our part all set up, ready to go. I failed to actually add in to that part. So we do need to either at the model level or at the fixture level would be better, is add our tabs. So let's add our 2 tabs in. Now, you need to make the decision when you're doing something like this, because of our fixture avoidance, do I want to machine the tab as if it's the part and take them to 0, or do I want to stay away from them a distance, right? And you'll see that here. So if I was to go back when we first machined this, I'm going to go ahead and grab my pocket clearing, and we're going to paste that in. And now I am going to edit pocket clearing because I want to do tool orientation in this case. Again, my Z-axis is this way. And now what you're going to see is based on that actual tool path, we have what's called fixture clearance. Now, the problem is the measurement of fixture clearance can cause a lot of problems, right? So what I need to do is make sure that, one, when I evaluate setting up my fixture, how much am I comfortable with my tool getting near that, right? So from a radial standpoint, I don't want to get within 50. Now, axial, you may actually want to say you can get closer. I usually match the two unless there's a special occasion. But as you can see here, when we look at that tool path once it's regenerated, is we are now machining much more down and under that part as much as we can, right? And this is something that as everybody is going to have to play with to find out what is going to work best for them to make sure that they aren't getting close. Now, some of you are probably still wondering, why isn't this getting close to that part or in here fully? Well, I would need to edit my tool because my tool does not stick out far enough to do so. So we're going to auto detect tool length. You're going to see it pull out a little bit more. Now, auto detect tool length only thinks in the world of the part, not the fixture. So again, we could go back, edit that tool. Again, we're going to go ahead and give that a dramatic length that I would never machine with, but I think a lot of you can get the bigger picture now, right? So again, say that sticks out 4 inches. That should give us much more clearance based on our regeneration. So I do see a question come through from Deep Thinker. Do you have to have it tapered? Surprisingly enough, yes, you do have to have it tapered because when you're thread milling an MPT tap, you can't actually set an angle to the actual threading cycle, right? So you can't create that. It needs the surface to drive it. Correct. So John is correct. So if you're using an MPT thread mill, and that thread mill is basically, 1 inch worth of threads, and you could just do a single swipe around. Now, I would model that hole as your minimum thread diameter. So then you could actually use your pitch diameter offset to bump it out to wherever you need it. So again, getting back to jigs and fixtures here, let's go ahead and take a look at our tool path. We should be getting much more underneath that part. Again, I still don't have that tool quite fully stuck out enough to avoid our jig and fixture. So we would have to edit that some more. Go ahead and turn off shaft and holder. Go in and edit that tool. Again, not the most realistic things, as you're seeing me force this tool to go in and do what it doesn't want to do. Any questions in the meantime outside of that? I see more and more people coming and going in chat. And if any of you have any questions at any time about what's going on, feel free to ask a question. Let's go ahead and go in and simulate with machine. And see what we're getting. I may have lied to you guys. I hyped you guys up about something that's not the actual problem. And I think I just caught it. I'm going to give you guys a minute to think about this. Why is it, do you think that tool path isn't getting further and further out? I'm going to cause a pause here because we are coming up at the top of the hour. Why do you think no matter what I change, that tool path was not going further and further down? And I can give you another view of this. If we look at this tool path a little more straight on here, we'll get you a full view of it. We were trying to get this tool path to get further and further down under our part. Now, why is it, do you think that is? Give you guys a moment to think about it. In the meantime, I'm going to go ahead and glance over at Discord, check in a few other places to make sure nobody's putting in tickets behind my back here. One of you all just texted me a lovely picture of yours truly for some reason. I know exactly who it is. It's another engine manufacturer. But let's take a look at Discord. We have anybody in Discord? I don't see any questions coming through on Discord. Nothing on the support tickets. Seems like it's a busy Friday. I don't see a ton of you guys in here right now. And I definitely don't see any answers in chat why that toolpath wouldn't go further and further down. Well, let's take a look. Tabs. You think the tabs are getting in the way? They shouldn't. The tabs run all the way down to the jig. Collision avoidance? Not necessarily. We adjusted our setup. When we did our actual radial clearance, we should be actually bringing that tool within 50. So that tool should be way down here towards the bottom. I have an idea of what it is, but we're going to find out here. Anybody else want to make a guess? We'll give you guys another 60 seconds or so. Makes it a little more fun when you guys get a pop quiz in the middle of this. Then you can write this off as training under the ISO certification. Machining boundary. There it is. I knew somebody was going to ask that one. That's what I'm thinking. I think, based on the machining boundary, and I'm more than certain I'm right, is by default, we're looking at a bounding box. And it just so happens what gave it away to me is the way this toolpath has always ignored everything I've done and stayed within that bounding box, right? Now, if I go in and I say no bounding box, and we hit OK, we should get a different result. Now, there's a second part of this that I could think of that we could go about that would give us even more. But with just that one thing, we have dramatically changed how everything interacts, right? So now we're seeing that pucker the bolt hole factor of 50 thou clearance from our vise and our jig and our fixture, but now we are fully getting under our part, right? So again, we could go back and change some things. A nice thing about the new collision avoidance here, I like, is we could actually go in and define staying away from our fixture surface in addition to, right? So if you all didn't know this, is if we go to the fixture and we actually create a fixture avoidance, pulls our fixture through automatically. Now, if I was to put in another 50 here, what is going to happen is you're going to see the math roll up down below. So now it's thinking to add that 50 to our 50 in our setup, right? So again, this is something neat. A lot of people don't really see because they haven't dug too far into it, but we can add additional fixture avoidance at a toolpath level, not just the setup level, right? Same rules would apply as if I was machining a part like this and I wanted to get it to tabs. One thing I might actually do, and now this is something that a lot of people are always curious about. We defined the tabs themselves as part of the fixture. I may not, right? And we did talk about making the tabs a part of the model so that you could machine the tab as close to the model specification so that it's easier to deal with later. Now, again, I've removed the tabs, but based on my pocket clearing scenario, this is where I could use model again at the toolpath level instead. So again, if we went in at just this toolpath and added our tabs, it's going to machine them technically within 20 because we have stock to leave of 20, and then do our avoidance of our fixture as we've rolled up. So again, there's no right or wrong there when you're doing something like this. Is you always like to think, I like to think in like a global setting, right? So this is global. Globally, what am I trying to achieve? And that's why I've stopped adding my tabs here in the model, because my global move is to machine the part, right? Same with my fixture. Now, those tabs later, if it's part of the fixture, can cause problems if I was to do, you know, my 2D contour, and then again, we do our tool orientation, Z-axis this way, and then let's say I was actually going to split those off, so we're just going to pick one little edge here and roughly here, and now I need to cut those tabs off at some point, right? Now, keep in mind, yes, I know we're hitting our part, guys, I get it. I'm the master of ruining the part. So now if we were to simulate that, but those were a part of our fixture, again, we can cause problems in simulation when we actually go to simulate that, right? So again, there's our tool path. If we simulate this, of course, we're going to get a collision against our part, but then we will also get collisions against our tabs as well. And we're seeing that down here in our collision tree, right? And we can view those issues, fixture/cutter collision, right? So again, something different for you guys to think about at the end of the day and how that is going to affect what you're doing. Any questions in the meantime while I clean this up and get it to work a little bit better? Go ahead and give you guys a little bit of time to put some questions out there. I regenerate everything on my end. See a lot of you coming and going. Hopefully you all aren't too busy or getting in trouble that you're watching all my content today. Any questions? Now we get a ton of video issues. Yours truly is slamming that machine into itself. Bad jigs and fixtures. That's what we're blaming it on, right? Any questions? We're going to go ahead and open this up. Any questions you guys have? Any issues you've had throughout the week? Anything in particular you guys want to see? Hopefully that explains MPT threads quite well. Bodzanova was correct in the idea that the machining boundary was the issue. Which makes me think, what happens if we come back to our original setup, see if we can't force something out of adaptive clearing to work the way we want it to. So again, we're going to go in doing a derive, and we're going to grab that and rotate that back up to the top. What do I think about Cloud NC? I don't know. I think it's interesting. I do. I think they, not just Cloud NC, I mean, there's also several other ones out there. I follow along with them, and I like the idea of automating programming to an extent. I just think a lot of you guys out there probably still drive carbureted cars because you're like me and enjoy the analog approach, right? So let's go ahead and take a look at this adaptive clearing. And first off, we need a tool path. And with that, let's make a couple of adjustments. Let's actually give this a selected boundary without selecting anything. So I've seen that actually make a pretty big difference as well on something. So I see perhaps a future video or tips on using 3-axis machining center as a lathe for small collet holders. So I've seen a lot of people do that, and I've done that in the past, and there is some tips and tricks about it, but usually the best way I can tell people is you're hacking up the actual G code when it's posted to make something like that happen. Seeing how you really don't have a tool changer or a parts checker or a parts chucker, or if you're really in a tight spot to do something like that, it's not a bad way to go. But I know a lot of shops that would love to make one-offs for almost less than what it's going to cost you to do it and fight with the machine to make it happen. So as you can see with a selected boundary, we're still not getting that stock recognition coming through in Fusion's world. Any other questions? Opening it up to everybody and anybody. Maybe if I play with this toolpath long enough, we'll get it to work, right? How's everybody's week been otherwise? You know what could be causing this? Let's go ahead and see if we can't get that stock model regenerated. Anybody have any questions? We're opening it up to all of you. If not, I'm going to go ahead and take a break. Going once, going twice. Break time. Seems like it's break time. I'm going to go ahead and take a break. If you guys have any questions in the meantime, throw it in chat. Let me know. When we get back, I'm more than happy to visit through that stuff. All right, we're back. I see a question that came in from Roy. How would you attack programming multiple parts that are very similar parts? Are you referring, Roy, to milling or turning? Because I've seen a lot of good things from the idea of a container method where you put parts into a component folder, as you saw me do with my jigs and fixtures, and then having, kind of like a template or a general profile of a part. Now, in my opinion, whether it be mill or lathe, there's not a right or wrong way, because I always look at my tooling and my approach from the tool only goes so deep and so fast. The part itself doesn't matter, as a lot of you have seen, and that would be more of my approach. Once I create my tool paths or my strategy, I think some of you know this, some of you may not, I very easily can jump over and grab tool paths from one part, copy and paste one or multiple moving over, right? So as you're going to see here, as I regenerated a horizontal tool path without tool orientation, I could very quickly go in, redefine my tool orientation. So we could go to our tool orientation, pick my Z-axis, again, bringing that information from one file into the other if you have something pre-programmed, right? So this is a way you could easily program your first part and then recycle all those tool paths again and reprogram in the next part. Now, the idea of the container method, if you guys haven't seen this, would be is to start a blank file. And as you saw me do on my jig and fixture, I would have a component that would just be part. right? Now, anything that goes into this component would be what's programmed. And how that works is if we jump over to manufacture, I am creating a setup before I actually machine that part. So again, as we could go in and we could say, you know, it's from solid. If you're going to work with different sized materials, you could define those materials. The real trick is that your model is going to be driven by what's ever in that part component, right? So now with that, now you're seeing a lot of my information as askew, which is causing a problem here because we haven't really given it anything. So we'll go to relative size box. But if I was to apply a couple of toolpaths, let's just throw a template at this to speed the thing up. We're going to go in and do my 3-axis milling. Again, face, rough, finish. But now at the design level, if I was to bring in a part that I wanted to manufacture, here's that part. And we'll actually leave this outside of the component. So here's one part I want to manufacture. And then you know what I would like to do is I'm going to go back and see if I can't find a second part. Where do we have here? I think it's over in my Milling Monday. So here is now another part I would like to manufacture. And then I think at some point I have a third part. So give me a quick second here. Now, going in, I'm trying to remember where I put that last part. Either way, the idea is still the same, that I'm now going to take my part and place it inside that other component, causing on the manufacturer side of things for everything to regenerate and reset up, right? But as you're seeing here is that new setup is coming through. We've gone in and programmed our part. For some reason, we are having a little bit of a craziness, so let's go back to our design. There is our part. And my Fusion is all of a sudden getting quite wild with different things. So let's see what should be coming through. My syncing is not working automatically, but as you can see, all of that stuff is machining in real time, right? So when I go back to re-edit this part, so we go back to design, and now I'm going to say, let's take this part out. Let's put our other part in. Again, let's pull this one out back under the top. And when we go back to manufacture, we're going to see here a regeneration. And again, by activating that setup, it's now changed my tool path to this part. So it's a quicker approach if you're working with a family of parts. You can kind of just drag and drop them and they automatically go through and set up and define what's going on for you. Any questions outside of that? Hopefully that answers your question, Roy, as to what you're seeing happening and how that's working. Did we lose you? Anybody else have any questions before I go back and start looking at some other things going on? So based on the post-processor actually defines whether or not your probe wear is adjusted. Again, it depends on your machine controller too, because it realistically is going to be based on radial. Now, your tool machine diameter or radial wear would also affect that, right? So obviously one is ×2 and one is the whole integer. Now that can be adjusted in the post-processor to define whether or not it's radial or diameter adjustments. I did just notice something in Fusion I need to check out here real quick. Give me a quick second, guys. I guess I could be looking this up with my face up here, still talking to you guys. Something just shocked me that I want to make sure that something bad isn't happening on my end that you're not supposed to see. Yeah, and don't need to get scolded. It seems like something has happened. In the meantime, with all of you out there, if you guys have any questions, feel free to put them in chat so I can get to those as quick as possible. You can also message me directly with the support email down below, and you can reach out to us via Discord now. I always try not to show you guys I'm not supposed to show you, and there it is. So I am allowed to show you. All right, cool. Let's bring this over so you guys can see it. Want to see? Yeah. Okay. You guys didn't know. Maybe we should read the instructions on here. What do you guys? How do you guys feel about that? Maybe on Fridays when there's new info that's released, I'll do a what's new. So, if you're like me and you never pay attention until you need to, there is now a new import CAD data from Link Design. And for the record, I don't get yelled at. I accessed this but from the what's new inside of Fusion 360, and I saw it at a quick glance. So if you're ever curious, you could actually go to what's new inside of Fusion. It'll bring you to this page that I'm looking at right here. So in the September 2024 update, which I'm shocked nobody has reached out to me about this, but down here, there's a brand new allowing you to actually bring your CAM data from a link design into your file to be able to use. So this is definitely something that's kind of shocking to me. And for those of you like me that are doing jigs and fixtures and palette work and stuff like this is going to be amazing, right? Like, how many times have we seen it? I think they have an example here in this video where you want to run multiple parts around a tombstone or around a jig, your fixtures, all of your modeling. You can now bring that through automatically from what I'm seeing. And I did see this, which is kind of funny, when I was messing around with that other part. I wanted to close it out real quick, that when we were just talking about the container method, is with that link design coming in, we saw that CAM data come through automatically. Now, seeing how this is new, and I have yet to read through the instructions, I'm curious to see what it would take for it to come into Fusion and what's it take to actually define it in our model. So I'm curious, does this have to come from a linked part directly? And does it automatically import? If any of you guys know, feel free to chime in down below as to what causes that, or if you guys even knew that. Or maybe we should have a watch party to actually review that video, right? So it looks like, from what I'm seeing, they're placing their part. Go into manufacture, import CAM data. So they said yes, and it looks like it prompted them. Go ahead and review this one more time. We're all learning something new today. Let's see what happens. Let's watch this one more time, see what they're doing. Just want to make sure there's nothing that we're missing. So it looks like upon placing your part and everything and jumping from one to the other, it's automatically prompting. So let's see here. Let's see if we can get it to do it again. I mean, that kind of freaked me out there for a minute. Let's start with that blank file again. So if we go to any one of our parts we're working on, let's jump back and we will pull the free support Friday. I guess yours truly just figured out what he's going to do for a Workflow Wednesday video. So let's save this. We have all of these tool paths linked to the part. And let's just go ahead and dump this part right in here. There's our part. There it is. Look at that. Who would have guessed? Did you guys know this? Let me know in chat if you guys knew this. This is super cool. So what now can happen is you can actually build out true palettes with multiple different parts all in real time. And what you're seeing is those tool paths coming from our original file. So I know, Matt Van Loo, if you're out there, this is probably going to be your best friend on that big old horizontal. Now seeing that you can actually link your parts and your toolpaths through. And let's see if we can break it. So if we go back here and let's say we get rid of a couple of things, and we hit save, we should, strong should, get that update to pull automatically through. And we are. This is awesome. There we go. So it works pretty clean, like everything in the design side with linking your files. I don't see any of you guys telling me that you knew this, so I'm going to take that for a fact that you guys had no idea that was in there or doing what it was supposed to do. Man, you learn something new every day. Maybe we should go look at the other what's new here. Granted, there's probably another one about to come out, right? So, from the manufacturer side of things, right? Neil, did you know that? I had no idea, man. Let's find out what other things that yours truly. Machine avoid tool paths. We knew about that. Improved left to right workflow. This was one that a lot of people sent me hate mail on. Of course, now you pick multi-axis as the second tab. If you all call me and I'm ever trying to tell you how to like do a tool path, if I tell you it's the 4th tab, it's now the 5th tab, okay? Just know you got a +1 everything. Undercuts and 3D contour. That's always been nice. Unnecessary cuts and 3D adaptive clearing. Well, we're not going to talk about that one. I think we've done enough damage to 3D adaptive clearing today. Spun profile, improved calculation. Oh, this was one I wanted to show you guys. This was a good one. Have you guys ever had that when you're doing lathe work and you, for some reason, it just will not give you a spun profile or arrows out your toolpath? Multiple passes in the trace strategy. That's new. I remember seeing that a little while ago. Thread mill inner diameter improvement. Tool libraries. Cool. Anything else? New vendor tools. Yeah, that's about it for the manufacturing area. But man, I can think of a lot of damage I'm going to do with this now. You guys are getting a sneak peek. We're gonna talk about this more in our Workflow Wednesday video. I might have to delay broaching this week. Outside of that, anybody have any other questions? Still got about 40 minutes left. I do have another thing I was going to show you on this part that occurred to me when I was doing some other stuff. Now, I guess the question is can I edit this here? Oh, you can you redefine stuff? Oh, you can't. Can you define fixture while doing this? Does this allow you to post out multiple things in one shot? Looks like we can post. See here. And I think I'm just going to play with this. I'm going to ignore you guys, and we're just going to play with this the rest of the time. And now I really want to go. Yeah, we don't have tool orientation in that post. Awesome. Roy, I'm glad I answered your question. This guy took a break too. He must be hourly, hanging out at the coffee machine, weren't you? Yeah, the container method works good by all means. And now it's got my gears turning on how you could set up really intricate different setups and different machine configurations to bring your parts through. Because in the world of how this works, now I'm really curious. How does minimize tool change work with multiple parts in here? Let's go for it. What? Yeah, you got me, Matt. Oh, you're in the Netherlands, 9:30 at night. Ah, I see. Matt, why didn't you tell me about this, man? Usually you're the first one to complain to me about it, some problem or issue with it. How far have you pushed it, Matt? Let us know in chat. So cool. Now, can you post all of this? Obviously, you could post all of it, but can you reorder all of it? Or is it going to ignore? Guess you got to use the same tools on a lot of this stuff. All right, let's go break some things. Now I'm intrigued. I may be able to do that for you, Neil. Come up with a right angle head video. I don't know. That's a good question, Roy. We could try it. Let's file save as this. Sample enclosure, save, and then can you give me another one? Let's say we get rid of this. Dump everything. File, save as. All right. I don't know where that's saving. So this is going to be a good day. All right. Where are we saving this stuff to? In November 15. All right. That's probably why it didn't show up over here on the left. Let's do it. Go back into design. Get back to our free support Friday, November 15th folder. Of course, now we got 2 of these. See here. I mean, I don't. Is it going to prompt it? I guess we just brought in. No, so it doesn't do anything if you don't have any tool paths. All right, hold on, though. There's 2 parts in here. Let's do this. Components, move this guy. Let's shift 1 left, 1 right. Okay. Now, if we go into manufacture, we're going to learn today. There's a setup, right? And let's hit. Now that there's a setup, yeah. So it looks like it's going to pull through that update. Yeah, so now there's a setup there. That's awesome. Now the gears are turning. Because now I'm curious how this works out. You could bring your setups through, but now the real fun is how do you go about machine simulation? Matt, do you know anything about that yet or not? That's my real curiosity. All right, let's see here. Because now that you can actually put them all on something. Here's that. Let's grab a couple tool paths from here so we're using the same tools. And for the sake of this, I'm going to remove this one. We don't need this. Actually, we're with the good old-fashioned delete, right? Now, if we go back, bring the latest one through. Yeah, I'm like you're saying. I don't know if they've meant for it to be at the level that I'm pushing it already, but my curiosity, like I said, is like now that we're using tool 1 a ton, if I go in and let's say we want to post everything and I want to reorder. Holy cow, it is reordering as best it can. It moved all the tool 1s up. That's crazy. It's there. It's almost there. It is almost there. Who knows, man? All right. Let's do this. Whether or not I have a Kurt Weiss in here. Let's see. Jigs and fixtures. I think I have a whole area dedicated. Where is he? Random parts, machine sim. No, it's got to be under content, right? There's that jig and fixture. Well, let's Kurt. Come on, Kurt Weiss, where you at? Might have to fix it here, but we're gonna see what happens today. We're gonna learn. We're gonna learn today. Back to design. Just to be safe, let's just go ahead and scrap all of this. Fine. Don't need the dummy part in here. There we go. And stock. I think that's different stock. That, what is this guy floating around out here? We don't need that. What all do we have? Like I broke my model at some point. I feel like we talked about this 2 weeks ago when I broke this, but what I want is basically what we have here. Okay, cool. So let's save that. Now let's build our tombstone. New component. To make Fusion happy. We're going to do things right. Let's see. Equal. Full. Go. You guys did this to me. Y'all ain't got questions. You're the ones that started this. I'm blaming on you. All right, there we go. Got our tombstone. I would like to bring in my vise now. And what we, hold on here. Let's get the vise out of there. I activated the top level. Now bring our vise in. Boom. Moving too fast for my own good. All right, so we got a vise. Let's that guy's grounded, so we should be good there. Our joint. Boom. And let's say we are going to copy, paste another one. Boom. Now we got two. We're going places, guys. And presumably we would need our, like part. Other component. We're going all out this time. Window machining part. You missed it. Last week we talked about the whole window machining. We could do another one. We did tabs earlier too. I don't know if you caught it or not. I like how when I just start screwing around with stuff like this, you guys get all quiet, you stop talking and chat, and then you turn around and like double the viewers come in. Like you guys just enjoy watching me completely screw things up. All right, let's see what we got here. All right, let's start with the container method. All right, we're going to manufacture. Of course, you're going to ask me that because there's tool paths tied to devices. Let's do it again. You only get one shot, apparently, to bring through those tool paths. All right, let's do this. Back to our vise. Wait a minute. There is no tool paths on our vise. That doesn't make sense. Huh. Alrighty. Let's try this. Let's go for this. Manufacture. Setup. Well, no, it's not going to use the setup, is it? Huh. Now I'm curious how this is supposed to work out. All right, let's just go for it. Back to manufacture, back to design. Let's go out and grab a part. Let's put Friday. Let's use the part we've been using all day, right? Okay, here's our part. Bring this guy in. And we're now going to do point bottom center-ish. Flip it in a little bit. And we need a second version of this. Here, their joint. I don't know how well this is going to work, but we're going to find out. Here's our cam data. Ah, see? Because there's two parts, it brought through two sets of cam data. Ha ha ha. Just about that now. Because you can't really do it that way, necessarily. Go back to the video, right? When in doubt, watch the video again. Kind of ignoring you guys in chat. You guys have any other questions? Meantime. For those of you watching this over the weekend, getting a good laugh out of it, I hope you're enjoying your beer. I have two parts here. You guys want to see what I'm watching? Pull this over here for you. They did the same thing. They duplicated their parts. Placed their parts wherever they're going to go. Oh, yeah, they got multiple. Look at that. They got multiple. Oh, they're suppressing it. That's how they're doing it. See that? Man. All right, let me get OBS pulled back. There we go. Already enjoying your beer. Roy, you're the man. All right. That's how they did it. They just went in and they were like, you know what? We're going to take these two guys and suppress it. And now that it's suppressed, that kind of makes sense. But if you were to post everything out, yeah, so it's only giving you everything but what's suppressed. No, it's me trying to figure it out on my own. Cosmin, do you have an article or something I can look at and get a good laugh out of? Hey, I just learned. I thought I was showing something that I shouldn't be showing when all of a sudden my link toolpaths come rolling through. All those years of telling people that you should keep your original part linked because all those toolpaths come in here. I'm just checking out how it goes. Now, I think 100% somebody pointed it out about the WCS. The WCS is going to be key here. How is it figuring? Because you do have your setups here, but you can't really change anything or your tool orientation. It's kind of like one and done. Hey, I've gone to the forum a couple of times with certain problems, man. I had a brand new Haas machine, and it was ahead of what some of the stuff in the background of Fusion was going on. But yeah, I get the idea. I see it starting to come through, but I guess your tool orientation is still there, other than yours truly put his parts in backwards. But I guess when you post that out, we'll switch out post processors. Yeah, see, all the problems are going to come now from the fact that your parts are like opposite facing and everything, right? Can you edit toolpath? Oh, you can't edit tool. Oh, no. You can almost do it. So close. So close. Man. I'm curious to see where this goes. Osman, you got any questions out there? Matt, are you still out there? You tell me, is this how far you got, or have you got it to work better than this? Because I could see the vision. What I can't see is the fact that obviously when we're bringing in these parts and placing them in design, that we still have to be very self-conscious about what is our WCS orientation, how is our part sitting square to everything. I think they did a little smoke and mirrors on that when they showed it. It's cool though. I mean, heck, this is light years ahead of what we had for the idea of like tombstone machining for sure. Oh, I was going to show you guys something else on this part real quick. I don't know. That's a good question. I mean, we could try it. Let's see. So if you go back to design, let's just break the link on one of these, right? By breaking the link, what happens in manufacture? Yeah, I mean, you're not wrong. It brought through the tool pass. The only problem I foresee now, you have full control, but the issue I foresee is you're no longer linked, which kind of sucks if you're going to go back and program this different. I see you're thinking, Roy. I mean, you're what, or not Roy, I should say is Neil. Yeah, I mean, I don't know if you could turn it on or turn it off or leave it as is, but from what I'm seeing, this is super neat that like all the years of like the way I imagine it now, right? Like you have full freedom to take a part like we're doing here and program it all up individually, right? Like, and this I did not, for you guys to know, I did not plan for this to happen. We're going from a 3D printed prototype to now an actual billet piece of aluminum to put on the car to test fit it. Now we've done that. We've probably done that on the oldest dinosaur of a machine in your shop. And now that we've done that, like transitioning into the idea of jumping into like tombstones and like mass production, super valuable to automatically pull this stuff through and get it all set up and defined. So I can see where that's cool that you can bring in your part, break the link, and then have an awesome starting point. And then you're right, you would just have to go through and redefine everything. So we've already kind of done this, right? So you have your tombstone, and then we also want our Kurt vise and yada, 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 right? So now it's like, boom, there's one side of the part. And then on our other setup, again, same thing. I'm curious, all right, is continuous rest machining going to work? Or is it, no, see, that's the thing, right? So your continuous rest machining is being driven from that other setup that we have suppressed. So you can't, this is wild. So you can't edit your tool path that's linked, but you can regenerate it. But yeah, I see where it's coming from for sure. But now you're going to get into that danger, right? So if you went back, let's say we break the link on this, and I'm probably going to get a terrible phone call weekend. All right. So now that you've done that, does your continuous rest machining still work even though you've suppressed everything, right? Most part, it looks like it's going to. Oh, see, it's going all the way down and around the part because it doesn't know what it's doing prior to. So you almost have to like freeze it as a place in time. Because without the proper information after the fact, it's just not going to know what it wants you to do. Right? Actually, that's our pocket clearing path. Hold on here. Let's get rid of that. Keep pocket clearing. Yeah. No, pocket clearing's doing the same thing. So like we thought, I see more messages coming in. All right, what do we got for messages? Hold on here. So we broke the link. You do have full control over the tool pass after breaking the link, but now I'm just seeing some craziness. Well, technically, in this scenario, we would have the same part in two locations. You're almost better off carrying on. Yeah, oh man, it's just so close, but so far. We would have to, basically, you would use this setup to trigger the other setup, and it gets kind of messy in the full deployment of this thing, right? So from the idea, and I'm going to jump back to design because it's easier to see it. Because your continuous rest machining, and we brought this part in, we got double the setups, double the things, right? So, awesome. So, Osman, I see your question. So you have a homemade CNC lathe for wood and mostly Most of your issues revolve around dealing with the limitations. Oh, you use GRBL on it. That's awesome. And Andrino, that's pretty neat, man. So, yeah, I don't know if you can turn the import off. I didn't see anything when I skimmed through all my settings, and I'm not going to pull my settings back up because there is stuff in there I know I can't show. But, yeah. You could use it as a quick toolpath library import. That's true. Can you use a REST machine to create? Yeah, so that's the problem. So what I'm thinking and what I'm seeing is like the way this is when we broke those links to try to like make this real world, we actually triggered more problems because the suppressed toolpaths now are almost causing the issues that we're seeing. Because like this pocket clearing is based off REST machining, right? And that REST machining is being drove by this body. But since we suppressed all of these toolpaths from the first setup to this part, right? We have two parts in here. And we have a setup 1, setup 2 for each part that, like, with all this suppressed, it doesn't know how to act for the second half of this. So, like, if I unsuppress this, right? And this is just throwing ideas out there, right? So now we've got all of our toolpaths here to machine it. We've got some other weird stuff going on out there. Okay. Yeah, I don't know what that guy is doing. That guy is lost. What are you looking at there, little guy? But yeah, so now that we have that REST machining stock here, our pocket clearing would pick up on REST machining back the other way, right? As you see, we're not machining all the way down the part as we've discussed. But the real problem is if you went in and you said suppress this whole thing, notice how it's causing me to do a regeneration down here. And that regen immediately dumps everything, right? So you would almost have to just hide everything one way or another, right? So you could just have this linger and then presumably, and this is where everything gets, I don't know if you guys know this, and I've kind of funny, is I would take this setup up here, right? So now this setup is technically my second part, and it's being driven from my first setup down here. So like to clean this up, this is setup. Let's label these better, right? So this is setup 1A. This would be setup technically 2, 4A, right? And then you have setup 2. And then this would be setup 2B because setup 1A is down here. That makes sense to any of you guys? Makes sense to me, right? So now you have these two setups down here just lingering that have no purpose, but you need them because you have your REST machining coming through. And what's really going to screw you here, now that I see that, is like, oh, I've changed, you know, blank, blank, and blank here in setup 1A. Well, that has to also be reflected in setup 1, or what is it, setup 2A, right? So it's like you're kind of damned if you do, damned if you don't. There's no real good way right now to really use, like, if you make your part square to the world, I think you have some leeway. And then, again, I guess, going back on my video on Wednesday when we talked about, you know, not having DW or TCP, like, you almost have to have it for the way they're coordinating this. Unless you can mass shift everything. Yeah, you're 100%. crashed files is never good, right, John? And it does. It creates a huge number of duplicate setups with different versions. I know somebody asked me the other day about, like, hey, why don't you ever use manufacturer models? And it's the same kind of dilemma that happens is, like, when you go in, I don't know how many of you have ever seen this. Let's say we go back to this part, right? Let's just use the simple enclosure. If you use manufacturer models, the problem with manufacturer model in a brand new set, can you take this out of here? No, you can't even get rid of it. That kind of sucks. So let's say we do a setup here and I want to use manufacturer model. Is upon creating my manufacturer model, I actually create a second set of bodies and which a lot of people don't understand that. So now that we have a manufacturer model for this particular thing, yeah, I can insert components and modify things. The real problem starts to lie in the fact that by selecting manufacturer model, I have actually forfeited my body. So I can't have my body carry through into my second setup for rest machining. So you kind of like lose something there as well. So it's super weird at the end of the day, the way they're doing all of this. Because like, here's my first setup, as you guys saw. I'm using manufacturer model 1. Let's say I go in and create manufacturer model again for my second setup. And now I create a new setup using manufacturer model 2. Although it's picking a body, notice how it's picking a body out of this model, right? So if you go in and say, you know, from preceding setup, continuous rest machining, I get this error because it can't transfer across manufacturer models, right? Like, super weird. Oh, yeah, and you're right. I mean, Deep Thinker, I see the way you're thinking, and I've kind of thought about that too, is like, we caused a lot of fucking chaos here. Excuse my language, but when you go in and you post all this out, you would have to go through. Oh, you guys didn't know it's my daughter's 3rd birthday as she's coming up here. Leona, do you want to say hi? Yeah, today's your birthday. You want to say hi to everybody? Here's your future of jitcadcam. Say hi.
Hi.
Show them your egg. Yeah. Happy birthday. Everybody's saying happy birthday to you. So, you're not wrong as you're thinking. As I would think the same thing, is you would have to come in here and, like you're saying, is toggle off your setups at this point, but you would still need those toolpaths to trigger the models. So it's kind of one of those things that you're damned if you do, you're damned if you don't. You're almost like, I can see the vision and I like the vision, Autodesk, by all means. It's close, but it's still missing that, like, I want to import for this model, this setup, right? Like, and I think a lot of you guys will agree, is like, the idea would be is like, when it gives me that prompt, it should prompt me what setup I want to tie to that model, right? That would be the way to go. I think that would be tenfold there. With that, you guys, we're starting down to the wire. We got 10 minutes left. I am going to go ahead and say thanks again for LN Engineering and Flat 6 Innovations for providing this model and buying me quite a bit of beer. But as you guys are seeing, obviously, we didn't go fully through that part, but I think we dived in deep enough to show you a lot of different outcomes to get there. We even got to explore this awesome new feature of bringing our CAM toolpaths through. I do want to leave you guys. I know you guys will still have questions here over the next couple of minutes, but we do stream quite a few days a week. If you guys want to catch it, next week we are doing Workflow Wednesday again. We are going to talk about broaching, if not possibly this instead. Let me know down below what you guys rather see. Is how is it that you could do broaching inside of Fusion, or would you rather see how this link toolpath thing plays out after I lose a bunch of sleep this weekend working on it? Now, if you guys want to support the channel, as always, we are more than open to you guys supporting in any way you can. Everything from nothing more than a like, subscribe, as well as sharing this content out to other people you may know helps us tremendously. But if you want to go above and beyond, as if you learned something this week, you can always buy me a beer. Nothing more than $3 down below to help support what my wife allows me to drink, because she doesn't allow me to buy beer for myself. So I'm going to open up the chat one more time. Does anybody else have any other questions? I might have to call this one early. My gears are just turning on how I can play with this more and break it. I will give this a few more minutes before I call it. Hope all of you guys enjoy this content. I know a lot of you go out and start leaving all kinds of comments and likes, and you start messaging me after the fact. You guys can always find me on Discord. I figured Discord was the easiest for a lot of you, that you're probably like me and you have a Discord. We are improving our Discord channel pretty dramatically as well over the next week, as I'm told. One of you great individuals out there reached out to me and said that you would love to modify our channel to make it much more up to date and auto posting this content. With that, I think I'm going to leave you guys to it. You know, it's not what you know, it's who you know. And you guys know Phil Brown over here at jitcadcam. If you guys have any questions about any of this, feel free to reach out to us directly through the multiple different channels to approach us. With that said, I hope you all have a great weekend. And Neil, Thank you, and I hope you have an exceptionally well weekend. Have a good one, guys.